Hi folks, we're going to take a look at the solution to number 6 on page 152. So the gist of the question is that we've got a building with 50 apartments, and if the rent is $900 a month, then they're all rented out. Okay, but if we increase the rent by $25 per month, we'll lose one apartment being rented. Okay, now this question here does have a bit of an unclear part to it. It tells us that the maintenance is $75 for every apartment. They almost imply that it means for all 50 apartments, even if they're not rented. But I think what they mean is that the maintenance is $75 per rented apartment. Okay, so if you read the question, that's not particularly clear, but looks like that's what they're aiming for. Plus, it makes it a slightly more interesting problem. Okay, so what we're looking for here is we're looking to find the rent to maximize the profits. Okay, so I'm not going to solve this in the grade 10 method, okay, because again, these types of problems, really it's the number of products that is the more common independent variable that we use. So in this case here would be number of apartments. So here we're going to say let x be the number of apartments. Okay, as opposed to number of rent increases. Now again, if you did solve it that way, absolutely no issue. That would be perfectly fine. Okay, but I would like to introduce you to this version of it. Okay, so the first thing we're going to do is we're going to find the price function. Okay, and since that's going to be a linear function, because the implication is that every time we increase by $25, we lose one apartment. So I need to find the equation of this line. So here, one point would be, well, when I've got 50 apartments, the price is $900, and if I increase the rent by $25, my number of apartments will go down by 1. Okay, so here the slope will be nice and easy because it's just 925 over 900, so 25 over -1. So it's just going to be -25. Okay. So just my y2 minus y1 over x2 minus x1, and I'll just stick this into y equals mx plus b. So I'll pick that first point, 900 equals m, -25 times x, which is 50, plus b. So b will just be equal to, let's calculate that quickly, so 900 plus 25 times 50, since I'm bringing it to the other side, so 2150. Okay. So my price function, okay, again with x being the number of apartments, is just -25x plus 2150. So my revenue is just going to be x times that, okay, because the number of apartments rented times the price of each one. So that's just going to be -25x squared plus 2150x. And my cost function, okay, so again, we're going to make the assumption that they mean that the maintenance is $75 per rented apartment. That if no one's living in the apartment, I guess there's no maintenance to do there. Okay, so here this is going to be $75 times the number of apartments that are rented. Okay, so now we can build our profit function. So the profit function is just revenue minus cost, so -25x squared plus 2150x minus 75x. Okay, and we simplify that, -25x squared, and this is going to be, so 2100, oh sorry, that's going to be plus. So 50 will bring us down to 2100, so it looks like it's 2075x. Okay, now notice here that this is a quadratic with a negative leading coefficient, so it means it does make sense to find a maximum profit. So that critical point that we find will have to represent a maximum because of the type of function it is. So here we have -50x plus 2075, and so here make that equal to 0. So x is just equal to, well, here I'll write it out, 2075 over 50. Okay, so let's calculate that. So 2075 divided by 50 gives us 41.5. Okay, Now again, my expectation is that you're either testing signs on either side, or you're making reference to the fact that, okay, this is a quadratic with negative leading coefficient. Okay, max, since it's a quadratic with a negative a value. So that's how we know it's an absolute max. Okay, this is where we have to be careful though, because remember x represented the number of apartments. So it doesn't make sense to be renting out 41.5 apartments. So there's two things that you can do. You can either check the profit at 41 and 42 and see which one of those is larger, or you can realize that 41.5 is exactly in between 41 and 42. And what do we know about quadratics? We know that quadratics are symmetrical on either side. Okay, so from here, even just this little diagram, okay, 41 and 42, okay, just shows that you understand that either one of these would give the same profit value. Okay, your other option is to take 41, stick it into your profit function, 42, stick it in your profit function, you would see that you would get the exact same answer. Okay, so now we found the value which, in this case here, values, which maximize the profit. So now I have to go back and see what they were actually asking me, and what they want is the rent to maximize these profits. Okay, so I'm going to have to use my price function. Okay, and in fact, if I check the price at 41, okay, the what do we have? We have negative 25 times 41 plus 2150, or the price at 42. Okay, negative 25 times 42 plus 2150, and let's check both of these here. Okay, so here I got negative 25 times 41 plus 2150 gives us $1,125 for our rent, and negative 25 times 42 plus 2150 gives us $1,100. Okay, so either one of these two rents would give us the same profits. So I guess from a business perspective, it would make much more sense to get that 1,100. Might as well give your tenants a break. Okay, since both of these will just give you the same amount of money in the end. Okay, so that's it for this one.